This video demonstrates Ironwood Electronics products, services, and capabilities. Ironwood Electronics, founded in 1986, is designs and manufactures high-performance IC adapters and sockets. We have over 5,000 standard products in our catalog. We do custom designs almost half a dozen per week. Our staff is mainly comprised of electrical and mechanical engineers. We are a ISO 9001 certified company. We have a distribution worldwide. Regarding capabilities, we have a heatsink design simulation. We have electrical signal integrity simulation capabilities. All of our designs are done in 3D CAD SolidWorks software. From SolidWorks, we directly export to the GIPS-CAM manufacturing software, which is programmed and directly fed into CNC machine to manufacture precise and accurate components. We have state-of-the-art CNC machines that can machine tight tolerance. Swiss screw machines can machine very small, accurate cylindrical components. Regarding the adapter side, we design PCBs using a PADS layout software. We have experience in controlled impedance design, embedded resistors, micro vias, blind and buried vias, very small trace and width, rigid flux PCBs. From a manufacturing perspective, the PCBs can be screen printed, pick and place using a MyData SMT equipment, and reflow using a wafer paste or regular convection oven. So we have a full SMT line for assembling components onto PCBs. On the right here, we show the major product families of sockets and adapters. We will go through them in detail in the next few slides. In this slide, we are going to talk about engineering sockets. Engineering sockets are mainly used for verifying chip designs, whether it is able to function as per its design. Our engineering sockets are mainly comprised of elastomer as an interface solution. So the picture here shows a ball grid array device compressed onto a wire elastomer. The other end of the wire elastomer interfaces to the target board, thereby an electrical connection is made. We have a vertical silver particle elastomer shown here, and we have a flux circuit based gold cap elastomer shown here. The other pictures here shows various socket designs using elastomers. Like for example, this one shows a 2 mounting hole socket design as well as testing a package on package. That means you can stack a processor inside the socket, then place an elastomer on top of the processor and place a memory on top of it, thereby able to make the whole stack up of 2 packages to the target board and able to test it. Another design here shows a back-to-back assembly of the socket. Another design shows here open top for accessing the top of the chip either for thermal purposes or other options. Another socket design here shows a gold-plated socket components mainly used for RF shielding. Another option shown here is a epoxy mounted socket on a production board where there is no mounting holes and no soldering can be utilized. Most of the times there are components on the back side of the board. We can able to provide a backing plate with the supporting post, or we can create a custom insulating layer that can go over the components, thereby protecting the components when the back support is needed. We have a wide experience with these engineering sockets. As in the left side bar shows, we've been doing these over past 18 years. The next slide talks about production and burn-in sockets. The contact technology mainly used here is pogo pins or spring pins. We have a wide variety of low-cost spring pins for burn-in sockets, and we also have some high-performance spring pins for production test. Recently, we have developed an elastomers that can withstand production environment. That means 1,000,000 touchdowns. The advantage of these elastomers is you can able to replace the whole elastomers at one time as opposed to replacing individual pins when there is a time for a replacement is needed. We also have offset plunger pogo pins for testing Kelvin measurements, mostly for power management type of devices. We also shown various socket designs using heat sinks and different compression plates for a QFP type of devices or a multi-level production test sockets. This slide compares both the elastomer and the spring pin contact technologies that are used in engineering as well as production side. This column lists the individual characteristics, and then these are all the 4 different contact technologies that are compared. Like for example, the SG product group is mainly used for an engineering test, has a 27 to 40 gigahertz bandwidth. We also have a silver button elastomer, which is called a GT product group, which has a 75 gigahertz bandwidth. So you can compare the need of your applications using this matrix and narrow it down to which contact technology is suitable for your applications. Similarly, this page details out more focused on spring pins. Spring pins are used in both engineering test, burn-in test, as well as production test. Some of the pins, like for example, you need 500,000 touchdowns. You can able to use this pin on a 0.5 millimeter pitch ball grid array type of a device with other characteristics such as force per pin. So this slide talks about engineering adapters. On the left side, you can see that we've been making these adapters over 25 years. That shows how much experience we have with these type of products. Engineering adapters are mainly using a printed circuit board and a low cost or a high performance socket on the top side and an interface to customer's target board. A lot of times customers' target board had a footprint, whether they are a PLCC or a quad flat pack or a quad flat no lead type of device footprint. So the bottom module we create that emulates customers' devices and goes on to target board, and then the top module can able to plug into the bottom module, thereby customers can able to do prototype verification, test and debug, or even emulation of the device using an emulator pod even before the devices are developed. We also create a rigid flex, a probing board with socket that can be used with oscillators or logic analyzers to verify the functions of device to the target board, and you can able to visualize those signals using scopes when it is communicating to the target board. This particular example is for a memory device connected to the target board and interfaced with some matched impedance connectors, which able to access the communication of memory signals back and forth from the memory to the target board and so on. This slide talks about Ironwood Electronics production adapter capabilities. A lot of times customer have a target board made for a particular device, and those particular devices are obsolete. So in this particular case, a PLCC device is obsolete, but it is available only in QFP. So Ironwood Electronics manufactured a PLCC to a QFP adapter, which receives the QFP package on the top side and has an interface to mount onto a PLCC footprint on the target board. We manufacture these adapters in volume and able to package them in trays or tape and reel depending upon customer's need. Various other examples shown here are a BGA to a BGA conversion, SOIC to a PLCC. In this particular adapter is a SOIC to a SOIC, a pitch conversion. The target board has wider pitch, whereas the devices are available in high density pitch. This adapter helps to solve that problem. A SOIC to a DIP converter, and we also do some high pin count BGA adapters for connecting devices to the target board as a pluggable solution. This slide talks about an equipment. We work with our partner to distribute this. In almost all situations, an IC device that is sitting on a board has to be characterized at various temperatures to verify its functionality at various temperatures. This device has a head that is controlled by a software screen to provide whatever the temperature is needed. For example, we can set up a temperature of 125 C and the tip on the head reaches 125 C, which is directly transferred to the device. So your device top surface is maintained at 125 C, so you can verify whether your device is working there. You can able to change the temperature in the software screen to -40 and able to quickly reach the negative temperature and able to verify if your device works at negative temperature. We can customize the head to accommodate various IC devices or various interfaces to sockets or soldered devices, etc. This slide shows our facilities overview. We have a 24,000 square feet building. The production area is a clean environment. We have an ESD, automated SMT assembly area, and we also have the machining area separated with state-of-the-art CNC machines and Swiss screw machines. A typical process flows like this. A customer sends a IC drawings and mentions their requirement. Our sales and application engineer work with customer to match if there is a standard product available. If it is not, then a concept will be shown, followed up with the quotes and drawings. Customer approves and places the order. Engineer designs the product, designs being approved by the customer, then documentation generated, components manufactured, parts assembled, and tested, inspected, and shipped. So as you can see here, the biggest lead time is due to components manufactured, and that is due to availability of schedule in our CNC machines. The rest of the things are done in very dynamic, quick fashion. And we can able to accommodate the component manufacturing as well based on customer's need. This slide talks about what we can do. Like for example, we can do custom designs in 2 days, manufacture the complete custom designs in 10 days. We can do heatsink simulation services for the customer, signal integrity simulation for the customer. All of our components are 100% optically inspected using our automated optical inspection equipment. The in-house machining capability allows us to turn in products very quickly to customer on all custom designs. This slide shows our presence throughout the globe. Our headquarters is in Minnesota. We have a distribution all over North America, Europe, and Asia. Thank you.